Now our main lemma bounds the number of times that we can delete an edge and then add it back in. Let's look at the effect of deleting an edge and adding it back in on the level of the vertices. Let's take a particular vertex V, and let's say the current level of this vertex V is I. Now suppose at some later round we delete this edge from V to this vertex W from the residual network. What can we conclude about the level of vertex W when we delete this edge from V to W? Now if we're deleting this edge from V to W from the residual network, what do we know about the augmenting path? We know this edge itself from V to W is on the augmenting path. That means the level of vertex W is the level of vertex V plus 1. Now at the time that we deleted this edge, the level of vertex V might have changed from the earlier time. So it might not be level I anymore. But what do we know about the level of vertex V? We just proved that the level of vertex V never decreases. So this level of vertex V at this current time must be at least I. So this is at least I plus 1. So the level of vertex W at this time is at least I plus 1. Now suppose later we add this edge from V to W back into the residual network. Now if we're adding this edge from V to W into the residual network, then we know that the reverse direction edge, the edge from W to V, must be on the augmenting path. Therefore, at this current time, the level of vertex V must be equal to the level of vertex W plus 1. By our claim, we know that the level of vertex W did not decrease from earlier times, and we earlier showed that the level of vertex W was at level at least I plus 1. So this is at level at least I plus 2. Notice what we just proved. Suppose the level of vertex V is I. Now we take an edge going out from vertex V, and we delete that edge, and later we added it back in. After we added this edge back in, we know that the level of the vertex is at least 2 greater than what it previously was. So the level of this vertex increased by at least 2.